Hi guys, it's Mr. Robeson here. We are taking a look at probability distributions and discrete versus continuous random variables today in AP Statistics. All right, so first up, what is a probability distribution? Well, we've kind of gone over this before. We've said it's all the values that the variable can take and all the probabilities that go with it. All right, so if we toss a coin 3 times and let x stand for the number of times we get heads, well, we could get heads 0 times, 1 time, 2 times, or 3 times. All right, and here's the number of ways we could do each one. So there's one way we could get 0 heads. There are 3 ways we could get 1 head. There are 2 ways we could get 2 heads, and there's 1 way we could get 3 heads. All right, so that leads to this probability distribution. So remember, the value here is our x. So this would be our x. And this would be our p of x. All right, so these are each of the values, and these are each of their probabilities. We can write them as fractions. We can write them as decimals, whatever. It doesn't make a difference. We can also do this as a graph. Here we get a symmetric probability distribution. All right. And a random variable takes numerical values that describe the outcome of some chance process. The probability distribution of a random variable gives its possible values and their probabilities. So here's all the possible values it could be and all of their probabilities. All right, so next up, we have 2 different types of random variables. We have discrete random variables and we have continuous random variables. All right, first we're going to look at discrete ones. So discrete ones are going to be variables that you're going to get from counting something. They're going to be countable. So like the variable could be like 1, 2, 3, 4, 5, whatever. And it's each going to have a probability that goes with each one, like probability 1, probability 2, probability 3, and so on. All right, so these probabilities, these p's, satisfy 2 requirements. One, each one of them is between 0 and 1. Well, that's just properties of probabilities. And if we sum up all the probabilities, so if we do the sum of all these p sub i's, all these little probabilities up here, we're going to get 1. They have to add up to 1 because these x values represent everything that can happen. So that means these probabilities should add up to 100%. Right? So if we want to know the probability of any particular event, we just look at what x values make up that event and we add up those probabilities. All right, so which experiment would not be discrete? So which of these would not be countable? So roll a die 20 times and x equals the number of 5s. Flip a coin 10 times and x equals the number of tails. Pick a card 30 times and x equals the number of hearts. Run the 100-meter dash 40 times and x equals the time to complete the race. So which one of these is not discrete? So in other words, which one is not countable? All right, well, we'd be counting the number of 5s, right? So this is definitely discrete. All right, we flip a coin 50 times, we'd be counting the number of tails. So this is discrete. Like it would be 0 to 50. The first one would be 0 to 20. We're picking a card 30 times, we're counting the number of hearts, so it's going to be somewhere between 0 and 30. It's all whole numbers, and we are counting the number of hearts, so it is discrete. And finally, we're going to run the 100-meter dash 40 times, x is the time. So we're not counting this, we're timing. Timing this, we're not counting. Like we'd have a stopwatch. We could get hundredths of a second, tenths of a second, and so on. So we're not going to be able to count that, especially not on our fingers. So the answer, this last one is going to be continuous. So this is continuous. There'd be some other sort of distribution here to measure that. All right, next up. Find the missing probability of the discrete probability distribution. So we have these values for x, 0 to 5. We have these probabilities that go with each one of them. We want to know what's missing. All right, so the way we find what's missing is that all these probabilities should add up to 1. So if we add them up, .24 plus 0.16. All right, I believe that gives us 0.86. And then to find what goes here, it's just going to be 1 minus the 0.86, which is going to give us 0.14. So that means this probability should have been 0.14. Yeah, there it is. All right, so that is how probability distributions work. It's a real short one today. Tune in next time. We'll go over some more difficult concepts with them.